So there are bagging techniques and boosting techniques, and there is one class of other technique which is kind of a bagging techniques only, and that is called stacking techniques in ensemble models. And in this video, let's see what it is. Hey guys, my name is Shubhankar, and in this video we'll learn about stacking techniques. So this is a part 3 of this series. Before this we have talked about bagging techniques and boosting techniques, and today we will be talking about stacking techniques in ensemble models. So this is your real data science channel, and in this channel we talk about more generalistic approach toward data science, right? Because the idea is that you have to have a good understanding of fundamentals of data science, like on paper data science, of how a machine is making a judgment, how it is learning something, right? Yeah, so let's not waste much time and let's dive directly into the video. So before jumping in the video, guys, let me tell you what we have done till now. So this is the part 3 of the video, as you heard me say in the introduction of this video. And before this we have done part 1 and 2, in which we have covered bagging models, the fundamentals of ensemble model, the intuition behind ensemble models, and in the second part we covered boosting models. So if you are directly coming to the part 3 of your model, if you're just worried about stacking, this video will be enough for you. But if you are covering the whole ensemble methods, which I think you should see the whole complete series and follow up to here. So just give you a little idea what we'll do in this video. We will understand the idea of stacking, we'll understand what is blending, we'll understand the topic of meta model. All of them will comprise the idea of stacking for you, and then we'll just do a quick recap of ensemble models. That is really important, I think, these days, to learn, right? Because the idea is that why we have this series of ensemble models, specifically for ensemble model. Why didn't I pick any other series of on which we can make a video? Because ensemble methods are something that are highly used in industry, right? So it's like this, right? You might learn a lot of algorithms, and some algorithms like neural networks, they are highly effective, but when it comes to actual use cases, they act as a black box models, right? So you won't be able to explain why your model is making any answer or why it is taking any specific judgment. That will be the problem with neural networks, right? And if you go with the basic methods, they won't be able to solve your complex real world data problems. That's why ensemble methods comes up as a solution, right? Okay, the ensemble algorithms, whether it's regressor, cat regressor, adder boost, gradient boosting, XGBoost, random forest, all of them are something that actually are used to solve real world problems, not just for study purpose, away from the other models, right? Away models, most of the models, for example, linear regression, logistic regression, although they form a lot of interview questions, but if you will see their actual use in industry, you won't find many, right? Until your data is quite straightforward, right? So yeah, let's dive to our topics for the day. And the first thing is idea of stacking. So if I just let me make a new slide, and idea of stacking. So we have studied about bagging models, right? Bagging models, which is a kind of ensemble models, which says that you have multiple models in a parallel fashion, right? Let's say this is M1, this is M2, this is M3, and this is M4. You have multiple models in a parallel fashion, and all of them will make a judgment. There would be a bootstrap sampling involved. All of them will make a judgment, and on the basis of that, you will, let's say this gives you 1, this gives you 0, this gives you 0, this gives you 1. So majority says 0, so your answer would be 0. This was the idea of simple bagging model, that it works on the idea of wisdom of crowd, and it takes the majority as an answer. One thing that we discussed in bagging models is that all these M1, M2, M3, M4 would be same, right? All models will be same, right? So if it's DC entry, all of them would be a DC entry. If it's SVM, all of them would be a SVM. If it's logistic regression, all of them would be a logistic regression. If it's K means clustering, or K nearest neighbor, sorry, not clustering, K nearest neighbor, all of them would be K nearest neighbor. So that is an idea that it comes up with. Okay, all of these models would be same. The only difference between bagging and stacking, is this is the first difference. First of all, that we have these models are different, right? So when we have these models are different. So when we talk about stacking, these models M1, M2, M3, M4, they are allowed to be different, right? Now it could be that M3 and M4 are same, but that allowance, okay, now that thing is permitted that the models could be different is there, and that is why this model stacking models are different from your bagging models, right? That's the first difference. Other thing is that if you just do this one change, okay, models could be different and all the other structure remains same as that of a bagging model, then it's not called stacking, it is called blending. Okay, it is called blending. Okay, in that particular case where your bagging models are, all the models, individual models are same, all your weak learners are same, right? In that particular case it is not called stack, it is not called bagging, and it is instead called blending, right? Now if this much is fine, for you, let's see what stacking is then. Okay, if this is blending, now your question would be, Mangesh, we started with understanding stacking, so if this is blending, then what is stacking? Stacking is little bit different, guys. Stacking would be that you have these models, okay, you have these models, and let's prepare a whole structure, okay, you have the data, okay, you distribute this data in a bootstrap sampling fashion, right, to your 4 models, okay, to your 4 models, and all of these models are different, right? So as we talked, it's a blending approach, all of these models are different. So let's say this is a lowest regression, this is a decision tree, this is a k nearest neighbor, okay, and let's say this is an SVM model. So all of these 4 models are different, and so till now it is a blending model, all of them will give you an answer on the basis of majority, you will decide it. Now when we talk about stacking, we say that hey, all of them are giving an answer. So I have my training data, let's say I have 100 records, I'm training this on 100 records, so all of them are giving me an answer. So for example, first one I give 0 0 0 1, then I get 1 1 1 0 1 0 0 0 0 1, right? And on the basis of majority, I'm deciding, okay, this one would be 0, this one would be 1, this one would be 0, right? So now this structure here, the output of these models, this structure here, we fetch this structure basically, right? You can fetch this structure, and this structure is called data meta model, okay, meta model of data, right? So it's a machine learning model. If you see, all of them now will act as a feature. The output of linear regression acts as a feature, output of decision tree acts as a feature, output of KNN acts as a feature, output of SVM acts as a feature, and this is your final target variable, which was actually coming from your majority decision. But now we use this data, as a meta model, and we build a ML algorithm on this, build a simple prediction algorithm on this. Now this model here, the meta model here, it has 4 features, right, and it has 1 target variable, 4 features and 1 target variable. So you can build a machine learning model there, and you can then find an answer. So that's the difference. Let's summarize it once. That's summarized once. Bagging, parallel models and same model for each weak learner. For each weak learner you have a same model. When you have blending, right, similar to bagging, only models can be different. That is why it's called blending. You are taking a mixture of different kind of methods, you are blending them together. Then the last one you have is stacking. Okay, stacking works on, like, trains on a meta model. Now how this meta model comes up? Output of blending, right? So this is a summary of it, like what stacking would be. And it's important to know, right? I mean, it's again a highly trained classifier, and helps a lot of algorithm in stacking, helps you a lot in deciding multiple use cases on where you can use them. Now let's see the idea of what all things we covered here. Idea of stacking, blending, meta model. Last one will be recap of ensemble model. So what we have done in all these series, let me just quickly recap it for you, like in 60 seconds. We understood the idea of ensemble models. Okay, ensemble models work on the idea of wisdom of crowd. Okay, a lot of data out there, if multiple models are there, they will make together judgment, and together judgment will be better than their individual judgment, right? That was the first thing. Then after that, there are 3 types of ensemble models: your bagging, boosting and stacking. Bagging was you have models in parallel, they take a judgment and there is a bootstrap sampling involved. When you talk about boosting, we talk about gradient boosting, where we say okay, we try to reduce the residual errors step by step. And when we talk about stacking, we say okay, it's like a bagging model, but the idea is that you have models in parallel which can be different. And then stacking works on idea of meta model as well, that once you get a blending model, you take their output as a meta model and then you use that model as a new machine learning model, and you train your model on that, right? So that was a quick recap of it. I hope it was enough for you. And yeah, I expected this video to be short compared to the last videos. And yep, that's all I had for you in the Ensemble series. Ensemble models are again very useful. Any interviewer sitting in, if you have a project in your CV, you should have an Ensemble model as well, and you should expect question in your interview from Ensemble models. Yeah, that was all I had for you people, and thank you, and happy learning, and I'll see you again.